Okay, so we are here to talk about denaturation and how the environment can affect an enzyme. So first, let's remind ourselves what most enzymes are. So most enzymes are proteins, and if you'll remember, proteins have 4 levels of structure. So the first level is the primary level. It's just amino acid chain. That's what comes off of the ribosome. The second level, you start to see some helices, so like a telephone cord, or beta pleated sheet, okay? And you'll see multiple of those. So what you might see is that this starts to turn into like this. So it's still kind of straight, but it's got those structures. Then you start to see it fold in on itself. And so this is where we're going to see those R groups, because if you remember, every amino acid has that R group or that functional group that hangs off the bottom. Some of them are hydrophobic or nonpolar, some are hydrophilic, which is polar, some are positively charged, some are negatively charged, and they're going to interact with each other. So positives are going to look for negatives, nonpolars are going to stick with other nonpolars because they're hydrophobic. The polar groups are going to hang out with each other. They're going to flip to the outside so they can handle being around water because they're polar. And so what you're going to see is you're going to see your protein start to curl in on itself. And so you still see in some of these, well, you can't really see anymore, but alpha helices and beta pleated sheets, but now they're starting to look like a big hairball. And then some proteins are done here. Other proteins go up and join with another. So you'll have 2 tertiaries come together, and I'll do them in different colors so you can kind of see. Hemoglobin actually has 4. So some of them have this level, this quaternary level, others stop at tertiary. Okay, so just reminding you, most enzymes are proteins, and this folding is very important. So all of the way that it folds in these levels is super important because that's going to determine its function because it's its structure. So denaturation is a process in which the structure of the enzyme is changed. So the nature of the protein is its structure and function, so the way it is shaped and the function that it does. And so when you denature it, you take that structure away, which therefore changes the function. And so what we often see is you have this tertiary up here, and when certain conditions exist, it may start to unfold. Well, obviously, something that looks like this is not going to do the same job as something that looks like this. You know, if you're, I don't know, let's say your substrate fit down in this little area up here, so it's kind of square, there's really nowhere on here that's square for that substrate to fit anymore. And so to denature means to change the structure. Usually it means to unfold and therefore change function. Okay? I can explain how denaturation of an enzyme happens. Something is occurring, and we're going to talk about some examples of what that something might be, to break some of the interactions here. So if you had, say, a positive and a negative, that are interacting, there may be something that is stronger than those that breaks them apart. And so the protein begins to unfold. Sometimes it unfolds all the way out into a straight line back to that primary structure, and then obviously it's not going to work. And so that's what's happening, is something is breaking those interactions or those bonds and causing this enzyme to basically fall apart, just to unfold so that it cannot work. All right, so what are some things that can happen? The environment of an enzyme needs to be optimum. So optimum comes from optimal or ideal, perfect, however you want to say it. And the optimum environment for an enzyme is that environment in which the enzyme works at its best. So it's the best temperature, it's the best pH, it's just everything. I mean, think about what you need to really get going on your schoolwork. You might need a little bit of music, you might need a snack, you might need something to drink, you need it to be not too hot, not too cold. Those are all the perfect conditions for you to work as a student. Enzymes have the same thing. They have perfect conditions. They can kind of work some outside of those conditions, but they're not going to be as efficient. But when you put them in those perfect conditions, they can really work hard. And so that's what an optimum environment means. And so that's the first 3 learning targets. The next is I can explain how pH can affect enzyme function. So, with the pH scale, you have 14 as the top. you have 1 is the bottom and 7 is the middle, which is neutral. Okay, anything below 7 is considered an acid. It has more hydrogen ions. Anything above 7 is a base, and it has less hydrogen ions. And I believe bases have more hydroxide ions, if I'm remembering correctly. So what we're seeing here is a change in the concentration of H pluses. That can actually bind, those can actually bind to and interact with the enzyme and cause it to unfold. And so when you change the pH, you are going to cause bonds that can hang out in a normal pH. Let's say that you have an enzyme from your blood. Okay, and your blood has a pH of about 8, which is pretty close to neutral. Enzymes in your blood are going to need to be at that pH of 8. If you put them in a pH of 2, the increased hydrogen concentration, that acidity, is going to burn up, break up, however you want to say it, the bonds in the enzyme, and the enzyme is going to unfold. If you put them in a really strong base, really strong bases are also corrosive, it's going to corrode some of those bonds, so the enzyme's going to unfold. It's not always going to be that way, though. It's not always going to be that neutral is ideal. In your stomach, the pH in your stomach is about 1 to 2. So the enzymes that work in your stomach, they work best at that pH. They work best when there's a lot of hydrogen ions around. When you put them up in the blood, pH of 8, or in a basic situation, they're going to fall apart. So it's not always that neutral is the best. It just really depends on the enzyme and what it's, where it works. So if it's normally working in the stomach, it's going to need a lower pH. If it's normally working in the intestines or the blood, it's going to need a more neutral pH. But that's how pH can interact or interfere. So changing the pH outside of the optimum is going to alter the structure of the enzyme. And you'll see this with graphs. We'll talk about this a little bit later, but you'll see, if, like, for example, this enzyme that works in the blood, you would probably see it look kind of like this. So at the high and low pHs, it has almost no activity. But at that 8, that 7 to 8, is where it really works the best. All right, the second one is I can explain how temperature can affect enzyme function. So with temperature is a measure of the kinetic sorry, I can't write and talk, a measure of the kinetic energy of molecules. And so the more they're moving, the higher the temperature you're going to see. There's more kinetic energy, and so when you measure it, you get a higher number on the thermometer. When molecules are moving, they're more likely to bump into each other. So if you have all these little enzymes hanging out here, okay, and you've got these substrates hanging out, and they're all in this solution or whatever, if you heat this up, well, let's start with cold. If you keep it really cold, there's going to be little movement. So cold, little move. Okay, and so they're not likely to bump into each other. They will kind of, because they are kind of randomly moving, and so every now and then you'll get one that binds to each other. But when you heat them up, I don't know how to draw movement, but you can kind of get an idea. When you heat them up, they're now going to bump into each other, more likely. And so what you're going to see as you heat these enzymes and the substrate, the solution they're in, because they're moving faster, they're going to be more likely to bump into other molecules. They may bump into another, maybe an enzyme bumps into another enzyme and nothing happens because it is random. But when it bumps into a substrate, then that's when it's going to do its work. And so by heating up the solution, you're going to see the increase in rate. So what you're going to see on the graph is at low temperatures, you're going to see not a whole lot of activity, right? Because they're not moving very much. And then as you get it warmer, you're going to see more and more activity until a certain point. And then it's going to just crash to the ground. Because at a certain temperature, the energy of that heat, the energy of that kinetic energy in those molecules is going to start interfering with the bonds in the enzyme. And so at a certain temperature, this would be optimum up here, this high point. But up here, when you get to this certain temperature, is where you denature the enzyme. So what you see with temperature a lot of times is you see rate slowly increases to a certain point, and then it just crashes and burns because you get to a point where the temperature is so hot that you have now destroyed the enzyme and it can no longer work. And so it causes denaturation. The last one says, I can explain how salt can affect enzyme function. And so I'm just going to fold this over. Salt, because it is a molecule, it is an ionic compound, I should say. When you drop it into solution, and most enzymes work in solution, it's going to break into its different ions, okay, and they are charged. Well, these charges can interfere with the functional groups in an enzyme, and so we'll just draw a big tertiary structure. And so you start seeing these salt and these sodium and chlorine ions start to bind to and interact with the enzyme, and they can cause it to, they can actually outcompete some of the other bonds. And so what you might see happening is this enzyme starts to fall apart. And the reason being, the salt came in and it disrupted those functional group interactions that had it folded, and it causes it to unfold. The more salt, the more likely it is to unfold because the more ions you're going to have. So what you tend to see with this is as salt concentration increases, your activity decreases. So at no salt concentration, you've got pretty good activity, but as you add more salt, the activity of the enzyme decreases because the enzyme no longer has the structure. It has been denatured and it can no longer function. So that is what denaturation is, how it occurs, and what optimum temperatures mean, and then examples with pH temperature and salt concentrations. I hope that helps. Let me know if you have any questions.